Welcome back to Drones in America by MarketScale. I'm your host, Grant Giat, and I'm a partner and the unmanned aircraft systems team leader at the law firm of Adams & Reese. Today I am joined by Steve Gitlin, who is the Chief Marketing Officer with AirVironment, and they have quite an interesting story to tell that I think many of our viewers are going to find quite fascinating. So without further ado, Steve, welcome to the program.
Thanks very much, Grant. It's great to be with you.
Thank you. So let's start just, let's go straight to it. Tell us about the big news, because I think it's a very cool story.
Sure. So I think you're referring to our announcement yesterday that we'd closed the acquisition of Telerob, which is a German-based developer and manufacturer of ground robots. And we have acquired Telerob because we're expanding our portfolio. You can see behind me in this graphic, we're developing a portfolio of intelligent multi-domain robotic systems. And that's because our customers operate in multi-domains, not just in the air, but in the air, on the ground, on the water, in near space and space. And so we're shaping our portfolio to be able to match up with their mission requirements. And so we can deliver the kinds of integrated solutions that are going to help them succeed. And that's equally applicable to the defense market as it is to the non-defense market, because lots of customers out there are looking for efficient robotic solutions to help them achieve their mission objectives.
That's absolutely correct. The robotics aspect of the drone industry is one that isn't talked about as often, but nevertheless an integral part of the equation and what's going to make unmanned technology scalable and useful for more end user industries. So obviously that's a monumental, groundbreaking, great thing, and congratulations on that. What was the process that went into reaching out to the various target clients that AirVironment targets?
So we're actually celebrating our 50th year in business. We've got a long, rich history of disruptive innovation dating back to the first human-powered airplane and a series of solar-powered airplanes. And as we've developed those capabilities and technologies into products, we've been able to establish very robust, long-standing relationships with many of our customers. And it's those relationships that help us understand how to design and develop these solutions that are not just really cool looking and can do really interesting things, but at the end of the day, when they're put into the hands of an 18 or 19-year-old warfighter who has to rely on that device in very difficult environmental conditions to potentially save his life or the lives of his comrades, it has to work. It has to be reliable. And that close and long relationship helps us gather that information and learn how to constantly improve our technologies so that they remain on the cutting edge and they also remain as reliable and as effective as they need to be to satisfy their mission requirements.
Now, you mentioned cutting the edge, and I'd be remiss if I didn't bring up the interesting thing AirVironment's doing in regards to space and the relationship with drones in space. Tell us a little bit about the company's interest in outer space and how it kind of came to the conclusion to utilize drones and this type of technology to play a role in how we are exploring space.
Thanks for asking that question, Grant. It is a very timely and interesting question. We have been developing a technology for decades, let's say, probably more than 3 decades, that allows unmanned aircraft systems to dwell in the stratosphere for up to months at a time. And that technology is generally referred to as HAPS, which stands for High Altitude Pseudo-Satellite or High Altitude Platform Station. So imagine, if you will, a very, very long flying wing, in this case 260 feet long, which is longer than the wingspan of an Airbus A380, the largest commercial jet in existence. And the top of this wing is covered with solar panels, and it has 10 electric motors connected to propellers that drive it. And that HAPS system is designed to simply take off from a runway, climb up to stratospheric altitudes of about 65,000 feet, and dwell there, fly in a circle over a city or over a region for up to months at a time. Now, to be able to do that, you have to have a basic understanding of the atmospheric conditions at that altitude, which are fundamentally different from the conditions at sea level. And one of the main differences between sea level and that altitude is the density of the atmosphere, how many molecules there are in the air to generate that lift and generate that thrust using a propeller system. Now, AeroVironment has a history in this space. We actually set the world record for the highest flying airplane in level flight back in 2001 with our Helios solar HAP system. And Helios flew to nearly 97,000 feet above sea level in 2001. It turns out that the same kind of aerodynamic factors that allowed us to fly Helios at nearly 100,000 feet describe the atmosphere of Mars currently. And so when JPL came to AeroVironment about 7 years ago with a really hard problem, they came to us because we had that experience operating in that kind of a domain. And the problem was really, hey, do you think it's possible for us to design an unmanned helicopter that can fly around in the atmosphere at Mars? And we looked at it, and we looked at the science and the engineering, and we said, we think we can do it. And over the ensuing years, we proved it could be done. That resulted in our designing and developing and delivering much of the mechanical portion of the Mars Ingenuity helicopter, which, as you and your listeners and viewers may know, has had an incredibly successful series of test flights over the last several weeks on the surface of Mars. And just recently, its mission was even changed from technology demonstration to operational demonstration, which means it's going to start performing missions there on
Mars
to assess its validity on Mars. So you could only imagine how excited we are to be a part of that incredible story, and how fortunate we are to have been trusted so much by JPL to help them make this historic achievement. So that's really what we've accomplished in conjunction with JPL, and it opens up a whole series of opportunities for scientific exploration on other planets and other heavenly bodies where there is an atmosphere. So while Mars is in space, and the Ingenuity helicopter had to be designed kind of like a spacecraft to survive that 7-month journey and to survive all the vibrations of launch and the heat of landing and everything, it really is just like another drone that's operating in another atmosphere somewhere else in our solar system. NASA has plans to explore other heavenly bodies in the solar system, moons, planets potentially, and we look forward to contributing our expertise to be able to help make that happen, not only for us and for NASA, but really for all of humanity.
Right, and one thing I do want to say that's very interesting is we're entering a time where Martians, or I should say extraterrestrials, not necessarily from Mars, but from other planets, other heavenly bodies, is now becoming kind of a mainstream idea, whereas you couldn't talk about it even maybe 2 years ago without being called a conspiracy theorist. We now have congressional officials and mainstream media stations now discussing extraterrestrial life. And so I find that it's very interesting, the fact that we're now in this phase of extraterrestrial exploration. We're now actually approaching it with a different mindset. Is there any ways these devices or this technology can be utilized to gather information regarding possible extraterrestrial life forms?
Well, there's certainly some advantages to operating unmanned aircraft on Mars or on other locations in the solar system. And one of the main advantages is, as opposed to the rovers, which are traveling on the ground at a relatively slow rate of speed and take a relatively long period of time to get from point A to point B, a helicopter like Ingenuity can take a short hop and cover quite a lot of ground. And in addition, its perspective, its vantage point is looking down rather than looking out from a mast. So it complements the capabilities of the ground rover in conducting its mission. Another big difference is there are some areas that rovers can't get to, such as the walls of canyons or jagged areas that it may not be able to traverse. Whereas a helicopter like Ingenuity is able to fly above it and just hover there for a little while. And if it has the right kind of instruments and sensors on it, it might be able to conduct science and gather information that would otherwise be very difficult or impossible to accomplish with a rover. So whether there are extraterrestrial life forms or not, we don't really know that, but we'd like to think that helicopters like Ingenuity might help to find out.
Absolutely, because this topic is more interesting now than ever, and we're seeing like I said, more mainstream acceptance of the possibility that there is such life forms out there. So it's really interesting to have this technology be a part of the equation and participating in it. Now, in terms of when we're talking about outer space, and this is a little out of my, as a drone attorney, it's a little bit outside of my realm, but when you're looking at the regulatory environment of outer space, what goes into the, the regulatory approval process for a mission like this?
That's really a question you'd have to ask JPL and NASA. Our role is not so much from a regulatory perspective, but really to help solve difficult technical problems as they relate to unmanned flight and unmanned systems. So you don't have to go to Mars to talk about the challenges of regulatory issues, because right here on Earth, as you're probably well aware, given your role, we're dealing with a host of regulatory issues that once addressed are going to allow the full potential of drone technology to really manifest and deliver huge benefits to people right here on Earth. So whether it's law enforcement or defense, where we've been playing, or package delivery or asset monitoring and inspection or surveying, there are a host of really important applications right here on Earth that unmanned technology can really help address in a very cost-effective and safe way.
You're absolutely right, and we are seeing this technology become more unlocked. We had a significant shift over the past year with drone deliveries especially, and I agree, there's so much here on Earth we have to learn and benefit from in terms of drone use and what it means to truly be in America and have a regulatory environment that is conducive to advanced operations. Forget space. Even here, it's quite incredible to see something like that here on Earth as well. I want to talk about the two recent acquisitions and kind of how that sets up AeroVironment's plans for the future, because I know we mentioned the acquisitions and how significant that is. What are the future plans for the company that you can share?
So if we go back to the graphic that's behind me, Grant, the vision we have of the future state of our company is very much aligned with where we think technology is heading and where we think the needs of our customers are heading. And that is developing this integrated portfolio of intelligent multi-domain robotic systems. And so that's why I mentioned the acquisition of Telerob. It gives us access to the ground domain. When we acquired Arcturus UAV, you can see over my right shoulder these larger unmanned aircraft systems, the Jump 20 and the T-20. They're tremendous assets that dramatically extend situational awareness through both their ability to carry more and heavier payloads and their ability to fly for up to 24 hours at a time without landing. And those help expand the utility and expand the range of missions we can address. We've also bought a small company called Progeny ISG. It's kind of a group from within another company. And this is a group of about 40 software engineers primarily who are experts in artificial intelligence and computer vision and machine learning. And they're providing advanced, sophisticated algorithms and capabilities to our company that are ultimately going to allow us to do a couple things. Number one, generate more revenue through the sale of those as services to other customers. And two, strategically embed those high levels of artificial intelligence and autonomy in all these unmanned systems. And that's going to make our unmanned systems smarter, more capable, and more autonomous. Why is that important? Well, for the last 20 years, if we think about the defense market, US military and the militaries of our allies have been focused primarily on what's called counterinsurgency operations. Afghanistan, Iraq, other parts of the world, where we pretty much control the airspace. And we have an overwhelming superiority in terms of material and technology and quantities. But as the US military and our allies shift to address threats that are more from near peers and peer actors, other countries that have very large and sophisticated military forces, our solutions have to get smarter. They have to get more capable. They have to be more autonomous in order to operate in environments where we may not own the airspace and operate in environments where there might be technologies that interfere with radio frequency communication. So these devices, whether they're in the air or on the ground or in the water, they've got to be able to figure out where they are on their own, and they've got to be able to recognize targets or recognize situations and change their mission based on that. And the acquisition of the ISG team helps give us the technological capability to deliver those features and functions to our customers. So from a future perspective, we're very excited about the shape our portfolio is in, the decisions we've made, um, the ongoing high levels of investment in R&D that we invest in every year, and how integrating these all together so that potentially you could have ground vehicles carrying small unmanned aircraft, you could have larger unmanned aircraft carrying one of our switchblade systems. They'll all be able to work together in unison to do more for the people they're protecting and to be able to coordinate better against more capable adversaries.
These are pretty significant acquisitions, and you did a great job explaining how they set things up for a future where people can really benefit from this technology. And I really find the whole aspect of utilizing this technology in ways not only that can be utilized here on Earth, but also, beyond Earth, fascinating. And, I think what the viewers or what the audience would really appreciate is tell me one of the most interesting things in the process of your working with this, the utilization of this technology on Mars. What is one interesting thing you've either learned about the process or about Mars that may have been a surprise to you?
Well, I can't speak for the engineers who are intimately involved in the program. Of course, I have the fun job of being able to talk about all the cool things they create and they develop. But I know that every one of these products that we've developed has gone through a process of development that can take some time to get it to the point where it can be as useful and as robust and reliable as it is. And our team has an incredible ability to just persist, to persevere, and to address all the challenges that come up because inevitably challenges come up, and to be able to figure out solutions to those challenges and turn it into the right answer for the right customer at the right time. The Ingenuity helicopter project is a classic example. There were lots of people who didn't believe that a helicopter could even generate lift on Mars because the atmosphere is so thin, and because overnight the temperature goes down to more than 130 degrees below zero, if you can imagine that.
Is that Celsius or Fahrenheit?
That's Fahrenheit.
Okay.
Fahrenheit. It's pretty cold.
Still be very cold, right?
Yeah. So in fact, about 2/3 of the energy from the battery on the Ingenuity rover just goes to keeping the critical components warm overnight, so it can make it to the next day. But our team, in conjunction with JPL, they identified every challenge, every problem. They figured out solutions, and they did so with grit and with a resolute approach to delivering certainty to our customers. And if there's anything that I learned from this program, this project, and the success it's enjoying right now, it's how important that perseverance, that persistence, and that grit is to actually working through the problems that inevitably are going to come up.
You're absolutely right, and it's incredible to see how AeroVironment's able to work, with companies to perform these high-profile missions and these high-profile exercises. What is something in the not too distant future that we can expect to see from AeroVironment that might kind of also be along the lines of this high-profile kind of involvement?
Well, you can imagine at any given time, we've got a number of very interesting development programs going on behind closed doors. And while I can't open those doors today and talk about some of those things, I can say that across our portfolio, we're incredibly excited about the capabilities we're going to deliver. If you see over here, there's this device here called Quantix that has these funny looking wings on it. We introduced Quantix a couple of years ago with an initial idea that it could be really helpful for farmers. And we designed it so that it can basically, if you think about it, it's about as close as you can get to drones as an app, as you can imagine. What do I mean by that? What I mean is we designed it as a tail sitter. So it kind of sits on its tail. It's got 4 small propellers. It's shipped with a tablet. And on that tablet, you basically use your finger to trace a boundary around a piece of land that you want to survey. And you go through your pre-flight checklist, you swipe to launch, the aircraft takes off vertically like a rocket ship. And then at about 100 feet, it tips over and it starts flying around like a regular fixed wing aircraft. And the reason it does that is because it's much more efficient to fly in a fixed wing configuration than in a rotor configuration.
Right.
And that's why over the course of about a 45-minute mission, that aircraft can scan and digitize something like 400 acres of land underneath. And when it's done with and it programs its own flight path autonomously using its own algorithms. It takes all the photos, it stitches those photos together using GPS coordinates, and then it automatically returns to its launch site, tips back over into vertical, and then lands itself right on the ground. So you as the operator, you really don't need to do anything. That's why I say it's kind of really more like using an app than using a drone. And when it comes back, it basically sends all the imagery back to your tablet so you can review it right away. It's that kind of user experience that we think is going to be more and more important and more prevalent and more enabling of widespread use of unmanned technologies.
I agree
because
completely.
Ultimately, people don't want to be experts in, not let's put it this way, not everybody wants to be an expert in flying a little aircraft, but what people really want is the information those aircraft produce, or the packages they deliver, or the effects they provide. And we think that the investments we're making are going to enable that kind of seamless user experience, and that's really going to characterize the future of this entire category.
Right, and you brought up a really good point, Stephen. That's the whole notion of, you hit the keyword autonomy, and how important autonomy is into really projecting this technology into the future. And you are right, I think people are not interested in seeing this technology from being it's already unmanned, but we want it as autonomous as possible. People are interested in knowing how this technology can make their lives instantly better, and the more you can remove the human from the equation, the easier it becomes for that technology to make the human's life easier, because they obviously have less involvement. So I really want to thank you for coming on the program, Steve. This has been one of the coolest discussions. I'm just so fascinated by what you guys are doing to enable the technology to be utilized in outer space, and the role you've played in that. And congratulations on the big news and the acquisitions. I think it's setting you guys up for a very bright future, and you already have one already, but I think this is just going to elevate that. So congratulations.
Hey, we appreciate it, Grant. And if I were to sum up everything we do into one statement, it's everything we do is designed to enable our customers and stakeholders to proceed with certainty. So whether you're a war fighter or a farmer, or you're an employee of our company or a partner, we take all these technologies in robotics, sensors, software analytics, and connectivity, integrate them into these elegant, simple to use, reliable solutions, so that you, at the end of the day, get the information you need. You don't have to worry about it. And that's really why we exist and what we strive to achieve. And I really appreciate you giving me an opportunity to talk a little bit about the company and to answer your really thoughtful questions.
Thanks, I appreciate it, Steve, and I look forward to having you back on the program. I want to hear about other planets too, so hopefully you can help facilitate this technology with other planets. So thank you again, and we look forward to having you back on the program.
Thanks, I look forward to it as well.
Please join us next week for the next episode of Drones in America by MarketScale.